Hello guys, welcome to today's our lesson. We are talking about the application of integration, okay? So please see here, we have the curve for y equals to x minus 2 times x minus 5. And the problem asking us to find the area of the shaded region, right? Okay, so for this problem, you can just first consider the region below the x-axis is always a negative value, right? Because all the point is that, right? It's below the x-axis, that means the y-axis is smaller than 0, right? Okay. So for this region, you can just using the integration because that is from integration 2 to 5, x minus 2, x times x minus 5 dx, right? But here to remember that all the differentiation or all the integration means here, all the right, like rectangle here, the height times the y's, okay. So maybe here, please remember height is always a negative value. So it has to add it with a modulus to make sure that the area finally is a positive value, right? Okay. So then you can just calculate for this equation and you can just set from 2 to 5, x minus 2 times x minus 5 is for x squared minus 7x plus 10 dx, right? That is for this. And for x squared minus 7x plus 10 dx, we can set, then we can just try to simplify it a little bit, like it's 1/3 x cubed minus 7 over 2x squared plus 10x from 2 to 5, right? Okay, that you're using the power plus 1 over the new power, right? Then we can put 5 and 2 into it. So it will becomes into 1/3 times 5 cubed minus 7 over 2 times 5 squared plus 10 times 5, right? That is the upper bound. And then you can minus the lower bound, you can minus 1/3 times 2 cubed minus 7 over 2 times 2 squared plus 10 times 2, right? Okay, that is it. So you can put the values into it, like 1/3 times 5 cubed equals to 125 over 3, and 5 squared is 25, right? 25 times 7 is 175 over 2, right? And then we can add with 50, right? And here is for minus 8 over 3. And then we have to plus, maybe for 4 times 7 over 2 is for 14, and then minus 20, right? So here is minus 6, and here's 44. And for 125 over 3 minus 8 over 3 is 117 over 3, right? So the value can be considered as like 117 over 3, that is for 39, right? So this value is 39. So 39 plus 44 is for 83, right? So 83 minus 175 over 2, that is for negative 166, right? And then plus, here is negative 175 over 2. The final answer is minus 9 over 2, right? So that means here, the area below the graph, or the integration below the graph is negative or minus 9 over 2. But the exact area here has to add the modulus. So finally, it becomes 9 over 2, right? That is it. Okay, so here is for this problem. So for this kind of examples, like here, from A to B integration, from B to C integration, so please remember that this part or this area is above the x-axis, so it's a positive value, right? And this part is below the x-axis, so it is a negative value. So for each time the x value, like the negative value has to add a modulus, that means a real area here, right? So as you just using piecewise and just divided them into A to B and B to C, and then calculate the area separately, okay? That is for this problem. So for example, there's another example like here, y equals to x minus 1 times x minus 2, right? And the problem is finding the area bounded by the curve and the x-axis, right? Okay, so here we can say for the first part is 0 to 1, right? So we can say is 0 to 1, x minus 1 times x minus 2 dx, right? That is the first part. And the second part we can set is from 1 to 2, x minus 1 times x minus 2 dx, right? But here, remember that this is a negative part, so we have to add it with a modulus here, okay? That is it. So for the first part, we can say just trying to calculate the integration that is from 0 to 1, x squared minus 3x plus 2 dx, right? And then the second part, we can set modulus 1 to 2, x squared minus 3x plus 2 dx, right? That is it. So we can say for this part is 1/3 x cubed minus 3 over 2x squared plus, maybe here is 2x from 0 to 1, right? And this part is for 1/3 times x cubed minus 3 over 2x squared plus 2x from 1 to 2, right? So then we can set that just trying to calculate here, like for the first problem is like let me guess here. Here we also have to add a modulus, right? So just put 1 into it, that is 1/3 minus 3 over 2 plus 2, right? So then add them as a modulus, just put 2 into it, that is 8 over 3 minus, here is for 6, right? And then plus 4 minus the 1/3 plus 3 over 2 minus not minus 2, right? Add a modulus. So here you can calculate. The first part here is 1/3 plus 1/2, right? So we can say that the answer is for 5 over 6. And the second area here, you can just consider like 8 over 2 plus 3 over 2, that is 11 over 2, right? And here is for minus 2, minus 6, that is minus 4, that is for, I guess it's for 3 over 2, right? Okay, 3 over 2. Oh, sorry. Here is for 3 over 8, right? 3 over 8. So it's, sorry for that. It's 8 over 3 minus 4 minus 1 over 3 plus 3 over 2, right? So here the value is for 7 over 3 and plus 3 over 2 minus 4. So finally, we added a modulus is 4 minus 3 over 2 minus 7 over 3. So you can just try to simplify it a little bit, okay? That's for this example, okay? And that is the solution here. Okay, so that's for today's our lesson. We already learned about the piecewise function and trying to understanding how to calculate the exact value and the area bounded by the shape. Okay, so see you next time. Bye.